the bending light as it travels between two different optical mediums. Okay? As long as light travels between two different optical mediums, that light will always be refracted. Are we clear?
Yes, sir.
All the time. When light travels between two optical mediums of different densities, it will be refracted. Let me give you an example. Let's call this one the normal. Let's call this one air, yeah, water over here. Let's assume a ray of light is from here. So the ray of light is from water to air. It's from water to air. So what happens then? So you take a look at the optical densities of the two optical mediums between air and water. Which one between water and air, which one is more denser? Water is denser than air. So in this scenario, it is ray of light from a more denser medium to a less denser medium. So obviously, from a more denser medium to a less denser medium, how is it refracted? It is refracted away from the normal. This is the boundary line. It's called the boundary because it's dividing two optical mediums. This side is water, this side is air. So this optical medium divides those two lines into two. So guys, this is the normal. The ray of light was supposed to move this way initially. But because it's moving from a more denser to a less denser, it is going to be refracted away from the normal. So which means this is our angle of refraction, and this is our angle of incident, and this is the incident ray. And this is the refracted ray. Are we together?
Yes, sir.
Yes, sir.
Thank you. So, right now, let's continue. Now, we have another scenario. Scenario number 2. Now, let's assume now it's from air now to water. This is the boundary line. This is the incident ray. And this is the angle of incident, that's I, and this is the normal. From a more denser medium to a less denser medium. Sorry, less dense to a more denser. Remember, this was the predicted. Remember, the definition of light. Light is defined as the movement of light is a form of energy the movement of energy from the movement of light rays in a straight line. Okay, so we assume that light is moving in a straight line, but now because it's refracted towards the normal, because it's from a less dense medium to a more denser medium, and this is the refracted ray. Refracted ray, and this is the angle of refraction. So which means a ray of light from a less denser medium to a more denser medium is refracted towards the normal. Are we together?
Yes, sir.
Hmm. Can I continue? Hello?
Continue, sir.
Thank you. Let's talk about refractive index. Refractive index. Refractive index is denoted by letter N. Letter N. So it's defined in 4 terms. It is defined in how many? Defined in 4 ways. Number 1, in terms of speed of light. Number 2, in terms of angle I and R. where I is the angle of refraction and R is the angle of incident and angle of refraction. Number 3, in terms of real and apparent depth. Number 4, in terms of C, or the critical angle. So these are the 3 the 4 ways in which we can determine refractive index. Okay? Are we together?
Yes, sir.
Can I continue?
Yes, sir.
And then let's start with the first one. Number 1, refractive index equals to real depth divided by apparent depth. Okay? For example, if you have a pond full of water, and then you have the fish here, and then here, this is where the image of the fish seems to be. Remember, objects appearing under transparent mediums seems to be shallower than they are. In other words, when you see something under a transparent medium, for example, if you see a school of fish underwater, the school of fish is apparently deeper than you see it. Do that make sense?
Yes, sir.
This is the apparent depth. And where the real image is, object, sorry, is the real depth. So in this scenario, let's assume that this is 6 meters and this is 4 meters. So which means n is equals to 6 over 4. So n is equals to 1.5. And remember, n does not have units. It does not have what? It does not have units because it's a what? It's a ratio. Well done. Are we together? Hello?
Yes.
Yes,
sir.
Are you understanding so far?
Yes, I am.
That's good. Let me continue. Number 2, N, or refractive index, is equal to sine I over sine R. This one, from this equation, you can come up with so many other equations. This, when you are calculating refractive index, you can also come up with the equation used to calculate angle of incidence. So remember, N is equal to sine I over sine R. Multiply by sine R over here, multiply by sine R over there. This will cancel that. N times sine R equals to sine I. Divided by N over here, divided by N over there. So which means sine R is equals to sine I divided by N. So if you are looking for R is equals to sine inverse of sine I over N. This is when you are calculating the angle of refraction. Or you can calculate N equals to sine I over sine R multiplied by sine R over there, multiplied by sine R over there. So which means sine I is equivalent to N multiplied by sine R over there. Then I is equivalent to sine inverse. Remember, every time when you're using trigonometric functions, whether you use sine, when you're looking for an angle, it's sine inverse. Whether it's cos inverse. Whether it's tan inverse. Whether it's cosec, whether it's cot, whether it's whatever trigonometric ratio, you always do the inverse when you're looking for angle. So you should highlight those three. They are very important, okay? Those three are very important. And each applies on a certain scenario. So which means when you're in an exam and you are given a question for light, calculating refractive index using angles, expect the question to ask you to calculate angle of refraction or angle of incident or even the refractive index. So what you calculate, you'll be provided with a formula. It's a matter of substituting on whatever given formula. Does that make sense? Hmm? Hmm? Hello? Hello?
Yes, sir.
Can I continue? Number 3, N is equals to speed of light in air or vacuum divided by speed of light in a medium. E.g., for example, you know that the speed of light in air is equals to 3 times 10 to the power 8 meters per second. This is also called C, okay? C is what? 3 times 10 to the power 8 meters per second. And then let's assume that speed of light in medium in plastic is 2 times 10 to the power 8 meters, and you're asked to find n. So which means n is c over v. N is equals to c over. Are we together? Guys, are you with me? Where c is the speed of light in air or vacuum, where v is the speed of light of whatever medium you are investigating. Whatever medium you are investigating. So your speed of medium will be determined by medium from another. You know, different mediums have different speed of light. Light travels at different rates in different mediums. Do that make sense though? Yes, I think I do. So which means n in this scenario is 3 times 10 to the power 8 meters per second divided by 2 times 10 to the power 8 meters per second. Is that fine? This will cancel that. This will cancel this. So you're left with 3 over 2, which is 1.5. Remember, refractive index does not have what? Units. Are we together? Hello? Hello?
Yes, sir.
Thank you. I want to do the last topic. Total internal reflection. Diagram 1. What do you call this? Can someone assist me with the name of this? This is called a semi-circular glass block. We dilate a certain angle, and we are going to call this incident ray. And then the angle here is called the angle of incident. Let's assume that this glass has a critical angle of 42. And let's assume that our angle of incident is 30 degrees. What does that mean? It means I is less than C, isn't it? All the time. All the time, when our angle of incident is less than critical angle, we tend to understand that the ray of light will be refracted. There will be a refraction. And then this is R. And then this is the refracted ray. Refracted ray. Diagram 2. Same. Normal. Let's say now we dilate a bit. The angle of incident now, I now is 42. and C is also 42, meaning I and C are now. So what will happen? If the angle of incident is equal to the critical angle, the ray of light will be refracted along the boundary. Remember that line which divides two optical medium. We call it the what? The boundary. So this ray of light will be refracted along the boundary. Don't worry about my messy sketches. I will share with you a more cleaner diagram. So which means the angle of refraction will now be 90 degrees. And then the last part. Normal. Let's say I now is 45. C, remember this is the critical angle, still 45. What happens if I is now greater than C? When the angle of incident is greater than the critical angle, the ray will be reflected. This one we call it total internal reflection. So total internal reflection is a result of when the angle of incident is greater than the critical angle. Otherwise, there won't be any total internal reflection unless when the angle of incident is greater than the critical angle of that particular optical medium. Are we together?
We are together.
So from this, we can assume that n is equals to what's the formula for critical angle? Critical what? N is equals to 1 over sine C, okay? Or sometimes you say n times sine C equals to 1. Again, sometimes you say sine C is equals to 1 over n. Simply means the same thing. Are we together? That is for total internal reflection. And then we have application of total internal reflection. Do you know any applications of total internal reflection? Like this.
Periscope.
Wow. I'm going to list them here for you, and you are going to try and read on your own. Application of total internal reflection, periscope. What else? Endoscope. What else? Endoscope. What else, guys? Lipu. Do you know any? Mirage. A little mirage. So I'm going to stand. I'm going to stand there. Is there English like that? Hello?
Yes, sir.
Hmm. Do you have any questions before I dismiss this lesson? Hello?
No, sir.
Have a good night, guys. I'm preparing myself for work tomorrow.
Angko.
Oh my God.
Saya kita spicy cake.
Hmm?
Sweet dreams.
Kita
Judy. Judy is available.
Yes, how?
pergi malam aja.
Pergi malam mingguan.
Nah, dia lese.
In worrying.
Cara di malam orang.
Hurry?
Orang
Hurry?
ya.
What worry?
Samuele.
I'll say.
Hey.
Hey, how about you say? What's up, guys?
Okay, claro que voy a estar con esta lesson ese.
Yeah, kira yo, once and I say.